Hi, it's Holly, and I'm here to do a little problem about hydroniums, hydroxides, and pH. First of all, let's go ahead and review how they're related. So, hydroniums are the species associated with strong acids or weak acids. But if you have the strong acid concentration, you'll have the hydronium, the resulting hydronium ion concentration. If you have this, then you can get the pH. pH is equal to the negative log of the hydronium ion concentration. And you can go back to, if you have the pH, you can get the hydronium ion concentration by taking 1.0 times 10 to the minus pH molar. So it's a pretty easy step. If you have a strong acid, you figure out the concentration. That will give you the resulting hydronium, and it's just an easy step to get the pH. But what if you don't have a strong acid? What if instead you have a strong base? If you go ahead and calculate the concentration of that solution, if it's something like sodium hydroxide or potassium hydroxide, it will dissolve completely, and that will give you the concentration of the hydroxide. But still, you've got to figure out the hydronium in there because pH is dependent on hydronium. So how are you going to do that? Well, you have to remember that the hydroxide ion times the hydronium ion is always equal to something called the water product constant, and it is 1.0 times 10 to the minus 14. So okay, if we've got a base, we'll figure out the concentration and the hydroxide, figure out the hydronium, and then go to the pH. So let's go ahead and do a problem. And in this problem, I think we'll start off by saying you add 1.56 times 10 to the minus 4 grams of lithium hydroxide to enough water to yield, let's say, 650 mils of solution. And the question is, what is the pH? Well, it really kind of depends on, right? Do we have a base or do we have an acid? And the thing that we're talking about is the lithium hydroxide. Lithium hydroxide's not an acid. It is not only a base, it's a strong base. It's an alkali metal hydroxide. So the first thing we're going to have to do, let's see if I can find our sheet. First thing I'm going to have to do is go ahead and calculate the concentration of that strong base, which will give us the resulting hydroxide ion concentration. Okay, so let's do it. What we want is the concentration of the lithium hydroxide in moles per liter. What we got, well, actually we have a concentration. We have 1.56 times 10 to the minus 4 grams, and that's dissolved in enough water to yield 650 mils of solution. Now, it's not a concentration in the units that we want, so we have to do some converting. First of all, let's take care of those mils. And you can tell by doing that, the mils cancel. I'm left with liters, which is good because that's what I want in the end. And now it's time to go ahead and put grams on the bottom so they'll cancel, and moles on the top, because that's what we need on the top. So let's figure out the molar mass of lithium hydroxide. Lithium, if I round to 2 digits past the decimal point, is 6.94. Hydrogen is 1.01. Oxygen is 16. Add them up. So I'm going to put in here 23.95 grams per mole. And let's go ahead and do our calculation. Looks like 1.56 double E, change the sign to 4, divided by 650 times 1,000 divided by 23.95. Whoa! And if I go ahead and take that number and I put it into scientific notation, I don't know if you can see it very clearly, it's going to be 1.00 times 10 to the 1, 2, 3, 4, 5, the minus 5 moles per liter. So that number that we just calculated is the concentration of lithium hydroxide that we added. Now if we add that, it'll completely dissolve, and that will give us the concentration of the hydroxide. So the concentration of the hydroxide of this solution is the same. It's 1.00 times 10 to the minus 5 big M, or moles per liter. Well, that's getting somewhere, but it's not where we want to go yet, because we have to do the pH. Now pHs are based on hydroniums, not hydroxide. So what's the hydronium ion going to be? Well, remember, the hydroxide times the hydronium has to be 1.0 times 10 to the minus 14. So the hydronium ion is going to be 1.00 times 10 to the minus 9. And if we have that, the hydronium, it's pretty easy to get the pH. It's going to be 9. And that's a sample problem.